Good evening, it is Jeff Will here, reworking a problem for the second exam. So this was problem 4. This was requested by one of the students. Basically, our biggest job here is to look at the muxes. We have to look at the muxes to determine whether the muxes should have a 0 on the top and a 1 on the bottom, or a 1 on the top and a 0 on the bottom. So let's take them one at a time. Reg Desk is the, let's just take them by columns. Reg Desk goes around here, and we look at the mux. And when we have an R type, what we want is the RD field to go through. And the way we have it specified to us here, it's going to be a 1. So we're going to want a 1 here. And then let's just double check for load word and store word, and for branch, for load word, we want it. Store word and branch doesn't matter because we're not going to be writing back, but let's just check. Load word, store word, oh, those are memory, they're different, but store word does not write back. And so, or we don't want store word to write back. So on a load word, we're going to want to use the RT field, so we're going to need a 0 there. And that's about as clear as I can make it. Next, ALU Source. Where's that? Right here. That's this mux. So we take a look at the ALU Source, and for R type, it's going to be a 1. Well, we know that for R type, we're going to want the register. So this is going to be a 1. And then for load word, what do we want? Sign extended immediate. So we're going to want that down here. Now let's check. Store word, we want the sign extended immediate. That's good. And for branch equal, oh, wait, yes. We want the register 2 to come through for the ALU. However, on a branch, the sign extended immediate, which is important because branch is NI type, is used here to calculate the branch target address. All right, so mem to reg. Where's that? Here we go. Mem to reg. That's this one right here. We'll follow it down. And remember, mem to reg determines what happens with the writing of the register. So for R type, we're going to want the output of the ALU to go through, and it's got a 0, so we'll put a 0 here as a placeholder because that's what we want to go through. And then we'll check load word. Well, load word, we want the output of the memory file. We've got this. Now, it works so far. Let's find out. Store word 0. Oh no, what do we do? Well, hopefully most of you know what we could do, but instead we're going to say, wait, it doesn't matter. Why? Because store word and branch do not write back to the register file. Now, reg write. Reg write. R types are supposed to write back. Load words are supposed to write back. Store words aren't supposed to write back, and branches are not supposed to write back. This is completely wrong. It's completely opposite. It is, it's not right. So, I had said that you can add gates if you need it. This is completely not right. It has a correlation coefficient of -1. All right, memread, well, R type, it's 0, and load word, it's 1. Let's go through memread. Okay, memread is here. It goes to down here. Memread goes right here. Now, I know that the convention is don't read unless you need to. Well, store word reads, okay? And so read is 1, the only time we need it to read, so that's okay. We don't have to mess with anything there. Now, memwrite. Do we want to write to memory? Do we want to write to a memory on R type? No, it's 0. Do we want to write on load word? No, it's 0. Do we want to write on a stored? Oh yeah, it's a 1. And on a branch, we do not want to write anything to memory. Since write changes the states, this matters. There's some don't cares in the memread, but all right, that's fine. That's what we'd expect. Memwrite gets to be left alone. Branch. Is this opposite? Do we need to not? Well, our type's not a branch. Load word's not a branch. Store word's not a branch. Branch is a branch. That works just fine. Now, ALU op. Okay, remember that our type is 1, 0. Memory is 0, 0. Store word, also a memory, 0, 0. And what's branch? 0, 1. Well, look, okay, everything's okay with that. So we don't need to make any changes of gates and so forth. And so let's just double check as far as the muxes go. Did we get all the muxes in here? Oh, wait a minute. Well, we said the branch was okay, but we never messed with this branch. Now the branch is going to be a 1 when it's a branch type, and then we want this to be a 0 or 1 based on the 0 flag. Okay, so if the 0 is 0 and it's a branch, if the 0 is 0, then the 0 flag is a 1. If the output is a 0, okay, it would be a 1. So if the answer is 0, then the 0 flag is a 1, and then together we're going to get a 1 here when we want to branch. Well, this is the branch target, so this is going to be 1, and that's going to be 0, because mainly this branch thing down here matched what our convention was. That's it.